Hello everybody, hope everyone's doing well out there in quarantine land. Today we're going to work on our second Mechinism Lab. We're going to go over three different mechanisms. They're going to be the bevel gear, the worm and wheel gear, and the cam and follower. Now, once again, this is going to go along with a worksheet that you already have in Classroom. It should be next to the assignment. The video and assignment should be next to each other. Let's start off with the first one, which is going to be our bevel gear. And the first question is speed increased, decreased, or constant? What we're talking about is if I turn the input handle right here, when we're going from the input gear to the output gear, is speed increased, decreased, or constant? Is that smaller gear going faster, slower, or is the speed staying the same? If we turn it just a little bit right here, you can see I tried to have markings on both of them. You can see, I think, a little bit better that way. All right. Now, we talked about this in our last few lessons as well. If speed is increased, what happens to torque? If speed is decreased, what happens to torque? Your second question is torque increased, decreased, or constant? The third question, if the input gear was the same size as the output gear, how would this affect speed and torque? So once again, if we had our two gears were the exact same size, how would that affect speed, torque? Would it increase it? Would it decrease it? Or would both of the gears be moving constantly? The last question is a gear ratio question. Remember to use your gear ratio formula, output over input, reduced by the greatest common factor, then write it as a ratio. The input gear has 32 teeth. The output gear has 16 teeth. All right, go through and you can answer those. We'll go to our second mechanism. Our second mechanism is the worm and wheel gear. All right, so when we start talking about this, you can see when I turn this, this one works a little bit differently. Obviously, this is the wheel gear up top, and this is a worm gear down below. You can see what happens when I turn that. Now, it says, what is the angle of the input shaft compared to the output shaft? What is the angle where the two shafts meet? And the easiest way to look at this is if we turn it up this way, you can see here is the input shaft, here is the output shaft. So if this was an angle, what angle would that be? All right, now this one we're going to do visually. We don't have our number of teeth on the worm gear, but if you just kind of watch how fast my hand is spinning and compare that to the wheel gear turning, is speed increasing, decreasing, or constant? And what does that mean for torque for the third question? And the last one, this is a new term for us, is the direction of travel reversible. And what that means is if we turn the output gear, can the output gear turn the input gear? Can I make that worm gear turn by turning our wheel gear? All right, so you can answer that question. The last one we have to go through today is the cam and follower mechanism. Okay, when we look at this, this is our cam and follower. This part right here is the cam, the part that looks like an egg. This part right here is the follower. You're going to see when I turn this how the two work. All right, you can see why it's called the follower now as we look at this. The first question, describe which is the cam and which is the follower. Just put that on your answer sheet so we know you guys have been paying attention to the video. The next one, what type of motion is the input? when we look at this, the handle is on the cam. What type of motion is that cam making? Look right there. That's what we're talking about. Next, what is the output movement? So once again, when I turn this, that's the output movement. How many times does the follower move up and down with one revolution of the crank? So what we're going to do is I'll turn this so it's at the highest point. All right, and I'm going to turn this one time around. I went a little bit farther than one time around, but you get the idea. If we go once around, once again we'll start here, one time around. How many times did that go up and down? And the last one is the direction of the travel reversible. So once again, if I push on this output, it might move down a little bit, but there's no way to get that follower or that cam to go all the way around by pushing on this. All right, so there's your answer for, is it the direction of travel reversible? All right, hope you guys are finding this not too difficult. This is going to be information we're going to use when we get back to build our pull toy. So make sure you guys are keeping up with this. If you have any questions, please make sure to email me, Ask in Classroom. I'll do my best to get back to you as quickly as possible. And we'll see you on the next one.